Hello, this video is basically an instructional video on the first step you should take or could take to summarize the article for our assessment piece in grade 9 science. The article is a fresh science article, and if I can scroll it down, its title is Continental Drift Shapes the Earth and Drives Evolution and Extinction. And what we're going to do, or what I'm going to do, is move through this article. I'm going to read it aloud, and I'm just going to cross out anything that is of no use, in my opinion, to my research question. So let us begin. So here is my research question, and now we'll just go back to there, and I'm just going to stick it somewhere where I can see and have it in my line of sight the whole time I'm doing what I'm doing here. So, continental drift shapes the Earth and drives the evolution and drives evolution and extinction. Good title. Planning to keep that to reread later. Forget meteorites, bin volcanic eruptions. When it comes to mass extinction, continental drift is the mega killer. I don't think I need this. Whoop, did that wrong. That's the one I want. So that's gone. And when it comes to mass extinction, continental drift is the mega killer. Now, mass extinction ties in with the evolution of flora and fauna throughout the world, because extinction is basically the end of evolution, isn't it? So I'm going to keep that line, but I know Mr. Malte Ebach is the scientist, but he really doesn't matter a lot when it comes to my assessment, so I'm going to blank that out. He argues that the dance of continents, the breakup, movement, collision and reformation of continents through time, creates the basic geographic and climatic conditions which drive the decline and extinction of species. Okay, that's a quote that I'm going to keep and look at closer and work out exactly how much of it is important, but I don't need the little bit in the front there. I bet that if you take a close look at the Cretaceous extinction, you'll find that the dinosaurs were already on the way out before the well-known meteor impact, says Dr. Ebach, who is about to take up a postdoctoral position in London's Natural History Museum. Okay, so I don't care that he's taking up that position. It may be important to him, but it's not important to my assignment, so I'm going to black that out. Now, listen to this. I'll bet that if you take a close look at the Cretaceous extinction, you'll find that the dinosaurs were already on their way out before the well-known meteorite impact. This is the word that really gets me. See how it says, I bet? That means he doesn't know. So what we've got getting into this scientific article are words that, he just doesn't know. So it could confuse us, and we could say, hey, look at that. The dinosaurs were already on their way out, because I read it in this article. We actually didn't, because that I bet negates, okay, it wipes out the fact, everything that's said after it, and I think we should just get rid of it, because it's not real. It's what his opinion is, and I know that the guy may be a an expert in his field, but there's no study to say this. It's just his opinion, and his opinion doesn't belong in my assignment unless it's backed by something, and it's not backed by anything. The cause, habitat destruction courtesy of continental drift. I'm going to leave that there. I don't think it needs to be blocked out. Remember, all I'm doing is blocking out the stuff I don't need first. That'll give me much less to read carefully to work out exactly what's best. Now visualize two continents such as India and southern China colliding into each other, and consider the amount of destruction coastlines will be consider the amount of destruction. Coastlines will be turned into mountains and deep oceans into shallow seas, he says, adding that with so much habitat loss, many species will decline and ultimately vanish. Okay, I'm going back up here and I'm going to grab my question, Control X, and I'm going to bring it down to where I'm working now. Okay, and now I'm going to read it again because, again, notice this is a comment that this doctor has made, and he's asking us to think about, that's what visualize means, the two continents, that's India and southern China, and we've been talking about that, and he wants us to think about when they collided together, and consider the amount of destruction coastlines will be turned. I don't like the way they've put this. See, they've put the little thing there and they've used it as a full stop. So really, consider the amount of destruction, and then you stop there. Coastlines will be turned into mountains and deep oceans into shallow seas. And then added that so much habitat loss, many species will decline and ultimately vanish. I'm very tempted to wipe this out. I'm going to wipe this out because, again, he hasn't shown us anywhere where to back this up. He's offering an opinion, and I'm not sure that that opinion is one that I want to put into my assessment. So I'm going to black that out. Now, you may not agree with me, and that's great if you don't. Your question may be different, and what he's written there may be perfect for your question, but I look at it and I think that's his opinion. That's not something that we need to work out. Dr. Ebach, and I'm not sure if I'm pronouncing his name right, bases his surprising idea about the extinction of species not to mention their birth and evolution. Notice how it says there not to mention their birth and evolution. That's where it comes back to our question, because our question is about the evolution of flora and fauna, and I'm believing that the extinction is simply the end part of an evolution. When the evolution doesn't work, on a powerful new technique called area cladistics. He created the technique in collaboration with the NHM professor Christopher Humphreys. I don't think that matters to my assessment that he created it, so I'm going to black that out. I'm not sure if this is going to help or not help, but I'm going to leave it there, and I'm going to look at it more closely on my next read through so that I can choose whether I like it or whether I don't. Dr. Ebach will explain area cladistics in its application and some surprising results at a media conference at 12 noon at the Museum of Melbourne. I don't need to know that. So it's gone. Area cladistics combined with the relationship between many organisms with places in which they are found, revealing... Area cladistics combines with the relationships between many organisms with the places in which they are found, revealing geographical patterns in time, Dr. Ebach says. I think I'll need to read that once or more twice, so I'm going to leave it there and decide later whether it's important to my assessment. These patterns tell us about where the continents were located when these extinct animals lived, and the journeys their fossil remains have undergone as they hitched a ride on the back of mobile continents. Well, that's mobile on the back, hitched a ride on the back of mobile continents comes down to our question, which is about continental drift, and so I'm going to leave that there, and I'm going to bring my question back down with me so that we've got it close by, and I always like to have it where I can see it, and that way I can okay, so there's my question, and here's our next. As an example, Dr. Ebach points to his study of 400 million year old trilobites, small marine invertebrates which lived about 590 to 250 million years ago. Their remains are found worldwide. Now, invertebrates are basically a shell creature like a crab or a lobster or something like that. And that there, I don't think the fact that he points to it is important, but I do like the fact that he's got a study. We may be able to use that study in our assessment piece. So I'm leaving all that there, but yeah, the fact that he points to it doesn't matter. So as an example, I can go and get rid of that too. Now, Dr. Ebach measured 30 different features on the heads of 100 individual trilobites from what is now Africa, North America, South America, China, Europe, and Eastern Australia. He fed the data, along with the location where each trilobite was found, into a specially designed computer program. I don't think I need to know that it's specially designed. Just into a computer program is really all I need to know. So I'm just going to black that out. The program identified the patterns of similarity and then built a branching diagram showing the degrees of relationship between the trilobites and their geographical home as relative distance. The program identified the patterns of similarity and then built a branching diagram showing the degrees of relationship between the trilobites and their geographical home as relative distance. Okay, so what that's saying is that the program took a snapshot of where the trilobites were when they were living and where they are now, is what I'm reading that to say. So if I had the ability to write on this, I would be putting a little note beside it saying what that means. But that's what I believe it's doing. It's saying, okay, the trilobites 300 million years ago were here, and now they are here, and they're finding them all over the place. Dr. Ebach and Professor Humphreys reported in April 2000 edition of the Journal of Biogeography that trilobites living in what is now southern and central United States were much closer to eastern Australian trilobites than those from Africa or South America. Okay, I don't think I need to know that they reported it, so I can say goodbye to that. But the fact that they were closer relations is worthwhile leaving there. Is it important? You're going to have to work that out later. They moved right around the world to the other side from where they had originally been placed geographically, he suggests. That suggests that the generally accepted position of ancient landmasses of Gondwana and Laurentia are wrong. Okay, now my question, for my research question, I'm not sure whether that matters. And I'm just bringing my research question back down to here so that I can have it directly above where I need it to be while I'm reading. So it said they've moved right around the world to the other side from where they had been originally placed geographically, he says. That suggests that the generally accepted position of the ancient landmasses of Gondwana and Laurentia are wrong. So what he's not saying that continental drift is wrong, he's just saying that it's drifted a different way, I think, is what he's saying there. I'm not sure if it's going to be useful for my assessment or not. I don't think it's going to be really of any use to my assessment. I'm tempted, and again, you need to read this for your own question, but I'm tempted to say that that doesn't matter for my assessment. According to Dr. Ebach, his study demonstrates that area cladistics works, that continental drift can be tracked without using conventional geological data, which is often unreliable or absent. Okay, I don't think we need to know that area cladistic works. Continental drift can be tracked without using... Okay, so it's talking about continental drift, which is a part of my assessment, so I'm going to leave it there for the moment for my second read through. Dr. Ebach says the technique will enable scientists to investigate the movement of continents, the surface area of coastlines, and the biodiversity of ancient life. The results promise to be immensely important. Okay, he says that he will be able to do something. He says that the results will be immensely important, but he hasn't said anything that's going to help me argue my case or do research for my case here. So I don't think that's important for my question. Is it important for your question? You're going to have to look at it. But he is saying that his method works and that it's going to be important in the future, and I don't think that matters to my assessment, so again I'm going to black it out. We will be closer to understanding the Earth's processes that have been responsible for wiping out thousands of species in a geological twinkling of an eye, claims Dr. Ebach. Again, for my research on how has continental drift affected the evolution of flora and fauna throughout the world, that I'm going to read it again, we will be closer to understanding the Earth's processes that have been responsible for wiping out thousands of species in a geological twinkling of an eye. Okay, so he's saying that this is something he's going to do. He's not saying that this is something he is showing. He's not saying why it's happening. He's not saying anything about continental drift. He's not saying... Well, he's saying that thousands of species have been wiped out, but he's not saying why. He's not saying anything other than I'm going to work out how that's happened. And that's not going to help me with my assignment, so I'm going to wipe that one out. Okay, here's one of 16 young scientists presenting their discoveries to the media, public and students for the first time at Fresh Science. Doesn't matter to my assessment. So that can go. We've selected them from 105 national nominations, brought them to Melbourne, trained them and thrown them to the media lions, said Niall Byrne, chairman of Fresh Science. It's all about focusing public media attention on Australian scientific achievement, and that is a noble goal, but it's got nothing to do with my assignment. So I'm going to black that out. So now that I've gone through here and read the whole thing and worked out stuff that I don't need for my assessment, and I'll bring this back up the top while we're doing it, I'm going to go back up the top and I am going to start again, but this time look at how much I need to read to help me do my assessment. I've gone down from, I don't know, 700 or 800 words down to probably 250 words that are important or might be important to my assessment. Next thing I'm going to do is go back through, reread each of the pieces that are left and highlight in yellow the important parts that I will be able to use in my assessment, and that's where I'm going to leave you today. Have a great one. See ya.